Good morning, guys. Today we're going to start a new chapter, Module 3, Topic 1, Lesson 1, putting the V in absolute value. So this is going to be some stuff that you will be doing in Math 3 next year. So this is kind of get you guys ready for that. If you can't tell already by downloading this that the worksheet looks a little different now. This is looks more of a slideshow, so we have a little bit more room to write things on. So we're gonna go to the warm up. Like I said, it's gonna be a little different, but it's gonna be a little easier with more room to write per problem, which will be nice. Look at the warm up. The graph of fx equals x is shown. Graph each transformation. Okay, so essentially transformation is how it moves. Okay, so with it being g of x equals fx plus 5, how it moves is that it moves this part here, dictates where the starting point is. So we were going to look at this graph. We're going to move it up 5 points. So 1, 2, 3, 4, 5. Just like that. And it's going to stay the exact same. Okay, so it just moves up at a new starting point. That's all it is. So we can draw a line just like that, and we'll just label this up here g of x. That's what transformation means. Okay, so it changes on how it looks. Okay, so that's problem 1. Looking at problem 2. 2 times f of x minus 3. So the first thing, and this is h of x, so the first thing is minus 3. So it's going to come down 3 spots. 1, 2, 3 is going to be one of the points. And because it's timesing, actually, yeah, that's right. Sorry. I'm looking at my sheet here and looking at a different one. And because it's timesing by 2, we're going to go, let me just double check here. We're going to go up 2 over 1 each time. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Okay, so it looks something like that. Because we have those, we can draw our line. You hold it, it makes it a straight line. And it'd be about like that. And once again, we just label this as h of x. Because it's times by 2, it goes up 2 over 1. Okay, so that's our h of x line. Now, we go to problem 3, which is the last one on here. It's saying j of x is 1/2 times f of x minus 1. So first thing we know, the minus 1 is going to start right at minus 1 here. Okay, because it's saying it's timesing by 1/2. Okay, the 1/2 is telling us what the slope is going to be. So we know it's going to be going up 1 and over 2. So how the other one was 2, essentially 2 over 1, we went up 2 over 1. We're going to go up 1 over 2. So each time we're going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Then it looks something like that. You hold the line straight down. It's going to give you a straight line, just like that. Oh, shoot. Sorry, guys. And then you just label this. We'll label it down here. J of x. And that's all you have to do for that one. Okay, so to graph them, you look at this first point here. Tells you where on y axis. And then you look at here. Tells you slope. Okay, so the first part tells you what the slope is. The second number at the end tells you what the axis is, where it's going to be on the y-axis. Okay. We're not going to go over those because we don't usually typically do those. Let me just read if this is what we want to do. Yes. All right, so getting started, distance is always positive. So the absolute value of a number and its distance from 0 on the number line. So absolute value indicates that with vertical bars, so anything that with a number like this or like that reads as the absolute value, okay? So with vertical bars, so -4 is read as the absolute value of -4. So for this to be absolute value of 2, -2, and all that. So follow your teacher's instructions to model each absolute value expressed in the x-axis of a classroom coordinate plane. Rewrite each expression without the absolute value symbol. So essentially what that means is when a number is negative, when you do an absolute, it turns positive. So this ends up turning into 2. Okay. Problem B stays as 2 because it just stays as positive. So it always goes positive. 2 or 1 minus 2 ends up giving you -1 inside. And because it's the absolute value, this comes back to be 1 as your answer. Okay. Now, this one gets a little more tricky. Because how this is written essentially is -3 minus 1 times -5 absolute value. So because we look at this as -1 times -5, that's going to give us +5, because a negative times a negative gives us a positive, plus, so -3 plus 5, which ends up coming to being 2. And then our after the absolute value is done, it's just the answer is 2. So this is a little easy with the absolute value. So giving you easier numbers right now. Okay. So we look at this one. -2 times 3 gives us -6 in the absolute value. So the without the absolute value symbol, it comes out to be just 6. 0 times 4, pretty easy. Any number times 0 just gives you 0. 12 divided by 3. So we gotta look to see, or -3, I'm sorry. We gotta look to see how many times does 3 go into 12. We should know this, that 12 times, or 3 times 4 gives us 12. So that will give us -4 in our absolute, because one's a positive, one's a negative. At the end of that, it is just 4. 8 divided by -4. So we should know that 8 divided by 4 gives us 2. And because one's a positive and one's a negative, it stays as a negative right now. With the absolute value, it changes to be 2. Okay? As I said, it's pretty easy with those. So write your observations about the absolute value expressions you and your classmates modeled on the number line. So that's essentially what we just did. Essentially, best thing I could say for you guys is distance is always positive or 0. That'd be the answer I'd say. So whatever distance, so if it's a -2, it's always going to be turned into a +2 if you have the brackets by it. We're going to skip this one. I'm not worried about doing that. We're going to start 1.1. We'll do a little bit of this, and then I'll call that a day. So graphs of absolute value functions. Follow your teacher's instruction to model the function f of x equals x on the classroom plane with your classroom coordinate with your classmates. So it's asking us to record the coordinates of the plotted points for f of x equals x in the table. Okay, so essentially, right here, we're going to fill in this part. So it says f of x equals x. So this is our x, and they're just asking us to plug it in. So for this column right here that I'm going to box in the red, it's pretty simple. You just rewrite what was in this box next to it. So -9, -6, -4, -1, 0, 3, 5, and 8. Pretty simple, because it's not changing, because it's just saying put in the value for x in where it says x. Now the next chart next to it is asking us to do the same thing, but now instead of putting just having the number 9 or the number for x, you're putting in an absolute value. So you do the opposite of it. Or not opposite, I'm sorry. You do the positive of it then. So if you have -9 in absolute, that give us 9. You have -6 in absolute, it's going to give us 6. You have -4 in absolute, you're going to get 4. -1 in absolute, you're going to get 1. 0 just stays 0. 3 stays as 3. 5 stays as 5. And 8 stays as 8. Okay? Doesn't change for the positive numbers, just the odd or negative numbers. Okay? They ask us to... Oh, no, let's just add them on there. Okay. Change all the plot points to the model function f of x equals x. So we did this part already. Okay. So we can just rewrite them in here as what we did up top. We jumped the gun a little bit and went a little bit, ahead of ourselves. I'm just checking something. Oh, there it is. I was like missing the graph for a minute. All right, number 3 is just asking us to describe how the points move from the graph of f of x equals x to the graph of f of x equals absolute value of x. So all we just say is, we could just say that the points of f of x equals x, so that's the function equals x, have negative x coordinates will reflect, meaning go on the opposite side, across x axis and be positive. So essentially what it means is that it's going to flip, so it's going to reflect, so you're going to see it on the other side. Okay, so let's think of like a mirror. You're going to see the reflection on the other side. All right, now they're asking us to graph these. So we're just going to zoom out. So we're going to graph the f of x function, or the f of x equals absolute value of x. So first point we can look at right here, 0, 0, pretty easy. That's going to be right in the dead center here. First point. Next point we can look at -1, 1, because this is going to be the new part right there. Okay, so this is essentially like our y. These are our y values right here. So we're on the y-axis, and these are our x's over here. So -1, 1, we go up to right there. we'll look at negative 4, 4. So we go over 4 to the left, 1, 2, 3, 4, and up 4, 1, 2, 3, 4, right there. We'll go 6, negative 6, 6, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And then the last one was 9, 9. So we go over 9 spaces to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we go up 9, which will be right there. So that's one half. Now we got to do the other half of the graph. 3, 3. We go to the right 3, 1, 2, 3. We go up 3, 1, 2, 3. We go 5, 5. Go over 5 to the right. Go up 5, 1, 2, 3, 4, 5. And then last but not least, 8. Whoop. 1, 2, 3, 4, 5, 6, 7, 8, right there. And your graph should look like a V. So now, when you put in the line, you line like that, and a second line like that. Your graph should look like a V, okay? So we're going to describe the characteristics. So we're just going to say here that graph looks like a V. Okay, that is where we're going to end today. I will pick up tomorrow on the rest of this because I don't want to spend too much on this. We'll finish the rest of this tomorrow, and then we'll move into the second part of this. Okay, activity 1.2. Okay, if you guys have any questions, please feel free to reach out to me. And looking forward to talking to you guys more on this tomorrow. Have a good one, you guys.